So welcome to the SQL Databases Foundation lecture. This is going to be week 1 if you're in Database Foundations, and we're going to be covering SQL. So before, oh, sorry, wrong slides. All right, so before we jump into actual SQL code, I just want to give you a little history about databases. So it first evolved in the 1970s along with the relational model in theory. And SQL was a structured query language for relational databases, essentially a language that allows us to search through databases in a more structured way. It is robust, scalable, and has solid implementations that do all the heavy lifting for us. So it offers a level of data consistency and integrity. So before SQL came along, dealing with databases was kind of a pain in the rear. So with the help of SQL, it allows us to have data consistency and a more structured language in order to search through databases. With SQL, it's a relational database. So what that means, it consists of tables, rows, and columns. And you can think of tables like subcontainers to store your data. And it's like an Excel spreadsheet. You know, you have your columns, and then you have your rows. And the rows is where you enter your data entry. So that's individual data that populates the columns. Excuse me. And the columns are vertical stacks of boxes that define the structure of the table. So kind of the number of columns that you have determines the structure of your rows, right? So when you're filling out information, you need to make sure that the information that you're filling out matches the number of columns that you have and matches the data types that each column requires, and it corresponds to what that column is called. So for example, if you had a table of customers, you would have something like customer name, customer ID, invoices, things like that. And then when you're entering those rows, you put like Susie, 25, or whatever it might be. So let's go ahead and make a table and insert some data. So what I'm going to do is open up SQL-tron, which is what you should be downloading if you're following through the curriculum. Okay, and let's say I create a database, so minimize this here. I'm just going to create a, let's see, I'm going to create a new folder and call it databases. Then I'm just going to open that up in Atom, my text editor. And then here I'm going to create a new file. I'm going to call it fun.db. So that's a database file. It doesn't have anything in here, so we're going to write it here. So I'm going to add this database. I will call it fun database. The database type is going to be SQL-Lite. And then we will need to put the pathway so we can connect it. So if we go back to Atom and we right-click the file, you can copy full path. And you can paste that directly into here. First, we're going to test it, make sure it connects. Perfect, it connects, so we're going to save. And then we're going to connect it here so that we can work with that database. So since we are creating a table, I'm going to show you how to do that. And then later we're going to discuss the keywords that I use. So if I'm creating a table, I'm going to do create table. And with SQL, if I wrote this in lowercase, it wouldn't matter, but it is standard practice for keywords to be capitalized, but it would work either way. So I'm going to create a table called customers, and then I'll have first name, and then I'll have the data type it is, so it's varchar 50. Then I'll have last name, varchar 50, and I'll discuss what all these means as we go along. And then let's have a zip code, which is going to be an integer. Okay, so if I execute that, I have created a table as we can see here. Okay, so now that the table is created, we see that we have 3 columns: first name, last name, and zip code. So now what I'm going to do is insert some rows. So if I insert a row here, I'm going to go insert into customers, because that's my table name. And what I'm inserting are values. And then I just need to make sure that it matches up to what the columns were. So the first column was first name, so we'll do Susie. And then we'll do last name, Q. And then zip code, we'll do 85014. And then we can go ahead and execute that. So now it has affected 1 row. So if I wanted to read from this table and I wanted to read all of the data from there, I can do select all, which is indicated by a star, from customers. And we can see that Susie Q is in there. So if we keep going, we'll go ahead and insert some more values. I want to show you what happens when you don't have your columns match, meaning that you don't put enough data into your row that fulfills all of the columns. So if I just try to insert Mary, right, just the first name, didn't put the last name, and didn't put a zip code, we get an error. Oh, I need to finish this thing here. Customers value. Okay. Well, that showed me a syntax error, which is a good error because it clearly told me that what I wrote was wrong. So I have corrected that. So I'm going to insert into customers values. I'm going to execute. And we have table customers has 3 columns, but 1 values were supplied. So that's letting us know that this is supposed to have 3 values in here, but we only gave 1. So we need our rows to match our columns. So if we do that, I'm going to go ahead and correct that, and we'll have Mary Jo and give her a different zip code. Perfect. And now I'm just going to enter some other values. Question here. Okay, perfect. All right. So then I'm just going to add some more rows. Let's see, who else do we want in here? Okay, let's see how many we got now. All right, so we have about 7 data entries, so that's good to start off with. All right, so now we have some data in our database, and we can go ahead and do that. So if we go back here to our slides, we can learn a little bit more about what you saw. So some of the basic SQL commands that you'll run into create. So as I just used it, I can create a table. I can also create an object. There's alter, which is related to objects, and that's basically like updating, changing information on an object. Drop is the same as delete, but that's for objects only. Then we have insert, which I just used. I inserted a row into my table, and that's for data. We have select, which you just saw as well when I did select all from customers, and that's kind of like a read, and that's going to be on data as well. Then delete, self-explanatory, deleting information. Update is when you're changing something. So if I wanted to update Susie Q's name to Suzanne, I can go ahead and use an update command to do that. You also might run into use, which is changing your database connection. So there are times where in production you'll have multiple databases that you're working with. And maybe for one command you need to use this database, but for another one you need to use this one over here. So you're going to use the use SQL command in order to change those database connections. Also, set is options for connection strings. So that's kind of saying how you want it to connect and those different options that are available for those connections. So you're kind of setting requirements for those connections, and that's what you'd use set for. Are there any questions so far?
No, can you hear me?
All right, so we'll go ahead and keep going. So also with databases, you're going to want to manipulate data, and you're going to use the CRUD operation system. So what that stands for is create, read, update, delete. And those are the 4 primary actions when manipulating any kind of data. So create is going to be the insert command, and you'll hear this over and over again in different programming languages when you hear CRUD operations. Essentially, it's create, read, update, delete. So as far as SQL is concerned, create is going to be insert, read is going to be your select, update is going to be update, and delete is going to be delete. So update and delete are easy to remember because they're the same, but remember create is going to be insert and read is going to be select. So let's go ahead and see what these CRUD operations look like. So if we go back to our database here, if I want to read, I can select, and we saw this before, select all from customers, and that's going to select all and allow us to read the data in our table. Now, if I wanted to put a limitation, let's pretend that I had a bunch of data here and I just only wanted the first 5. I can limit and then put a number, and it will give me the first whatever number I gave. So if I do that, we'll see that we'll get the first 5 data entries for this table. I can also retrieve data by picking exactly what I want. So let's say I don't care about the first or last name, I just care about zip codes. Maybe for marketing purposes, I can select zip code from customers, and then that will just give me all of the zip codes that I have here. And that with that information, I can do whatever I need with that. Also, if I need to filter data, we can select, let's say, last name from customers, where, and this is where we introduce the where keyword. So this is when you're selecting something, but you want it to be specific. So let's say I am looking for the last name of customers who live in the zip code 85014. So I'm going to say where zip code equals 85014. and I can go ahead and execute that. And then it will give me the last name of all the customers that have the zip code 85014. So these can get pretty detailed as far as when you're looking for information. You can be as specific or as broad as you need to be, depending on what you need to do with your data. There's also something called fuzzy matching, and that's when you're looking for something like, let's say you're looking for a specific word, or you're looking for a name that starts off a certain way or ends a certain way. That's when you can use fuzzy matching, and that's where I'm introducing the like keyword. So if I select first name from customers where first name like, and then in quotations, and you would see these percent signs. So if I'm looking for Seuss, I'm looking for this for anywhere in the word. I'm looking for these 3 letters. So I'll execute, and we find Susie. Now, if I want to find something that starts off with S, I can go ahead and execute that. So here, if you put the percent sign at the end, you're saying, I want words that start off like this. So if I gave it another go and we did JE, we have names that start off with JE. Okay? If I wanted to start it and have it end with a particular letters, let's say a Y. I don't know if I have any data with that, but we can go ahead and check. And we have Mary, Jenny, and Ricky here. So you can see it ending in Y. If I am looking for any word with the letter O in it, I can use the 2 parentheses, write the O, and execute that. But there are none, so we get no results. And that is where we're using the like keyword. Okay? If we wanted to order our data in a specific way, we can definitely do that, and that would be introducing the order by keyword. So let's say I wanted to select last name from customers, and I want to order by last name. It will automatically order it in ascending order. So if you wanted it to be in descending order, you would just put the descending keyword here. Okay, and then that is introducing our order keyword for ordering data. If we wanted to delete data, that's our CRUD operation delete, we can go ahead and do that. So I can delete from customers where last name equals Q. Okay, so I have deleted for wherever the last name equals Q. So if I had multiple customers that had the last name Q, then they would all be deleted. I only had one, which was Susie. So if we select all from customers, we can see Susie Q is no longer there. Okay. If I wanted to update, we can use our update keyword. So update customers, and I'm going to set first name equal to Annie, where first name equals Mary. Okay, so this is saying I'm updating my customers table and I'm changing Mary's first name to Annie. So wherever in my table I have Mary as my first name, I'm replacing it and I'm setting it equal to Annie. So if we look here, that should affect here, and this should be Annie Joe when we're done. So I'm going to execute, and then I'm going to select all from customers. And now we can see we have Annie Joe instead of Mary Joe. Okay? All right. So let's go ahead and continue on. And we have our data types. So when I was creating the table, you could see that I had varchar 50, and that's because I am selecting the data type. So the zip code was int, while first name and last name were varchar. So you can have 3 different data types. You can have character, numeric, or binary. Char, N is going to be a fixed size sequence of non-Unicode characters. Varchar is a variable size sequence of non-Unicode characters up to a specified size. Varchar is going to be a fixed size sequence of Unicode characters, and text is usually very large text and is not really used that often, but it does exist. So most often you're going to have the varchar and varchar. Numeric, you can have integers as we saw with zip code, and that's going to be whole numbers. There are different sizes of ints to help with storage allocation. So you might have a small int, a big int, tiny int, and that's just setting enough space in memory to allocate for that integer. So you don't want to use a big int when you just are using tiny integers because you're just wasting storage. Numeric is going to be a fractional component. Decimal is going to be the exact precision fractional number. So that's going to be a little bit more exact. So when you have like a long decimal, you're going to want to use the decimal data type. And binary is going to be arbitrary binary data. And you can have date, time, and date time are a few examples of that. So date is going to be in the format of year, month, day. Time is going to be hour, minute, second. Date time is going to be year, month, day, hour, minute, second. So it's just those two combined back to back with each other. Are there any questions so far? A tiny int would be like the number 1, whereas a small int might be like 400 versus a big int's like 6 million something something something. So it's a variation of size on the integers. And there are more specific limitations to those, which you can look up, but I don't know the exact stopping points for each. All right, so let's go ahead and jump into data manipulation functions. So we have string functions that we can manipulate the data with. So you can manipulate columns, you can manipulate variables, or you can manipulate strings themselves. So ltrim and rtrim will remove trailing spaces. Like, for example, if you had varchar, and you allocated 50 spaces for it, but you only took up 10, it will remove the trailing 40 spaces. Substring will take out a certain part of a string. So let's say you have the word hello, and you want to take out the ELL. And you could use substring to grab that part. Then we have upper and lower, which just means we're making everything uppercase or we're making everything lowercase. And left and right is we're inserting something from the left or we're inserting something from the right. So those are the different string manipulation functions that you can use. There are also math functions that are available. And we have power. So power is going to be something to a certain power. So the way that you write it is going to be power what you want and then comma what you want to raise it to. So if I want 2 to the second power, I would write power parentheses 2 comma 2. And that would be 4, right? 2 to the second power is going to be 4. Then we also have floor and ceiling. Floor is they both round to the nearest integer, but one is lower and higher. So what that means is that floor is going to, let's say we're looking at the number 2.5. Floor is going to return 2 because that's the nearest integer that's lower than the value, while ceiling will give you 3 because that's the nearest integer greater than the value given. And then we have pi, which just returns the value of pi, 3.14. I don't know how many decimals over it goes, but it does return the value of pi. Before I jump into defining tables, are there any questions? All right. So with defining tables, structure is essential to the efficiency and meaning. And keys are key. I say that because when you're dealing with a lot of tables, you need keys in order to connect them. So you'll have primary, foreign, and unique keys. So unique keys are going to be something like a student ID, right? If we're dealing with that, then every student has their own unique ID, which is a key to gain access to that student information. There are going to be foreign keys that are keys that link tables together. So let's say I'm looking at a student registration. I'm working for a school, and I have student ID and the student information, and it tells me all of their course information. But now I need to connect that student with the financial department, and they have their own table and database to work with. But the two things that are linking those two together is going to be the student ID. So that's a key that links the tables together. Also with defining tables, there are constraints, are limitations of what you can put into the column. So for example, if you're creating a table and you have these columns, there might be a default value that you want for that column if that information is not provided. I can't think of an example of it right now, but let's say someone forgot to put their last name, for example, and then you just have a default value of no name. That way it doesn't mess up what you're trying to do with that information, because later on you can go ahead and update once you get that information. So it might not be information that's absolutely key and vital. So you could put a default value for that and then later on update it. Last thing, indexes deal with the ordering of your data. So indexing is key for, organizing your information and pointing to certain information. Once you have indexes, kind of like arrays and indexes. So the index of an array will give you the information that you need. It's just an ordering of your data. So that is how we the key essentials of creating a table. Next, we're going to go ahead and talk about joins. So before I do that, I'm going to disconnect from this database here. And forget how to disconnect on this. Oh, right here. Okay, it doesn't want to work with me. Let me reopen this. And we're going to connect to this one. So this database that I am connected to is the same database that is in the curriculum. So you can see and play along with this. If we use some of the commands that we've learned so far, select all from Let's pick a table, albums. We see we have a bunch of information here, and we have a bunch of tables to work with. So here, we can go ahead and talk about joins and joining these tables to get certain information that we need. Because there are going to be times where one table doesn't have all the information that we need. So with a join, it's used when you have to combine data from multiple tables in a single result. So 2 tables, 1 column in common. So that's going to be something like student ID when I was talking about the financial department and registration department. The 2 common columns between those 2 tables are going to be the student ID. So we can join that information by using that student ID in order to get all the information that we need. So there are a couple keywords. So join and inner join. They're exactly the same thing. Join is just shorthand for inner join. So whatever you're most comfortable writing, they're both going to do the same thing. So they essentially create new rows by taking columns from each table and aligning them where the join criteria matches. And by join criteria, that means what we're using. So if we look at the structure here, we're selecting what we want from whatever table we're looking at, and we're joining another table using the column that they have in common, and we're looking for something specific. So we're looking where artist ID equals 1. So if I go ahead and show you what that looks like here, we have select name and title from tracks. And I'm going to join albums using album ID. If I could spell album. Album ID where artist ID equals 1. Okay, so I'm going to be joining the tracks table right here, and I'm going to be joining it with the albums table. Okay, if we look at the 2 tables here, we can see the only thing that we see in common between the 2 is album ID. So that's why we're using album ID to join these 2 tables, and we want a really specific result. I just want the albums that were made by the artist that has the ID 1. So if we go ahead and execute that, we can see our result here. Okay. And that is an example of a join. There are also, I see a question. I would prefer not to do the homework through the lecture because I want you guys to be able to figure out, but we can do examples of others. Let's see, write a query that lists out all. So for this, we can talk about what you would need to do, but I don't necessarily want to show you the answer. So write a query that lists out all the information of every track along with the name of the genre for each track, even if the genre doesn't exist for the track. Okay, so we're looking at probably the track table and the name of the genre. So if we look at the tracks, we can see genre ID. So we're going to probably have to join these 2 tables, right? So we are using tracks because we need track information, but we also need to list out the genre. Unfortunately, this track table doesn't give us the genre, but it gives us the genre ID. The only other thing that has genre ID is going to be the genre table. So you'll want to use a join using genre ID. So if we did genre ID from tracks join genres, and then you can change these two to respect to what it's asking for, but I'll only give you this hint. So when you're looking at that kind of information, you want to see what the tables have in common and what tables you might need to use in order to use those joins. Another join that exists are outer joins, which takes every row from either the left or right, but it will duplicate columns. So if you have common columns that are in common for both tables, outer join is just going to put everything together. So you're going to have a table, one giant table with duplicate information, which might not be the most efficient way of doing things, but there might be a reason that you need an outer join. There's also something called multiple joins, which is essentially a bunch of joins together. So if we look here at an example, I'm going to select artist.name as artist, let me spell that right, artist name, title, tracks dot name as track. And what I'm doing here is I'm just giving it another name. So we're looking at the artist's table, and we're looking at the name attribute, and we're calling it artist name. And then title's the same, and same thing for track. And then I'm going to grab that from the artist table, and I'm going to join albums using artist ID. So if we look here at artist table, where's that at here? Let me close all this. We're looking at the artist table and we're joining albums, okay? So if we're looking at these, we can see the thing that they have in common is artist ID. So that's why we're using artist ID. And now we're also going to join tracks using album ID. So if we open up tracks here, we see now these two have joined together, right? So now we have album ID and artist ID. If we look at tracks, we have album ID, which is totally fine because we've combined these two. Now, if we had combined tracks with artists, that would have been a problem, right? Because we don't have anything in common there. But since we join artists with albums, now we have access to album ID, which is then tied to an artist ID. We can now tie in tracks because it has album ID. So we're joining tracks using album ID, and then we're just going to order by artist name. So if we look at that, we have all of our artists, we have the title and their tracks. So this is the title of the album, and these are the tracks. So if we see here where I have artist name, that's why I did this, because I'm essentially creating like another table. Well, it's not really a table, it's a query, but it creates this table, a pseudo table, I guess. And we have artist name, title, and track. Okay, so then it lists all of that information for us. So there we have combined 3 tables all together to get one set of happy information. All right, so let's go ahead and move on and talk about views. So views are a reusable query providing a meaningful selection of data. The purpose is to represent a query to the user as a table would appear. So essentially, if I were to say this information, let's say this pseudo table is something that I want to use later on, right? So I can create a view. Now this isn't technically a table, it's just a query, but I can create a view for it so I can treat it like a table. And the way that you do that is you would write create view, the name of the view that you want, and then as, and then just your normal query. So if I just left this and I wanted to make this a view, I would just write create view, and let's say we call it track details as, and then we'll create a view from here. So if I execute this, I have created that view. So now if I wanted to select artist name from track details, it will just give me all of the artist's name. So it's now treating track details as a table. But be careful because this is not a table. It's just a query on a query. And depending how deep you go, it could be query on query on query, which may affect your overall performance and it may not be optimal for what you're trying to do. Now, for the purpose of this course and learning SQL, you're not going to be dealing with giant databases that are really going to affect your performance. So by all means, when you're doing the homework or the hands-on and you need to create a view, feel free to go ahead and do that. I also want to talk about transactions. So transactions, you can kind of think of them as a function, but a function that you can perform forwards and backwards. So essentially what it is, it's a grouped block of database actions that can be completed as a batch together. So when you hear the word batch, this is what it's referring to. And you could do it forwards and backwards. And an example of that is, let's say you're at a grocery store and you're going through the aisles and you're picking up the items, putting it in your cart. You go to the checkout, you scan all your items, they tell you the total, you swipe your card, it goes through, you get a receipt, you bag your stuff, you put it in your cart, and you go to your car. Now, that is a transaction, but I can do it in reverse order. Now, the key thing about transactions is the order that they're in has to be the order that they're performed. Like, you can't do step 4 before step 3 because it's going to mess everything up. And an example of that is, let's say you are returning all of your items, right? You're like, oh, I don't need any of this, I'm just going to return it. So you have to do everything that you did prior in reverse order. So you take the bags out of the car, put them in a cart, push the cart through the store, go back to the checkout lane, swipe your card so they can begin the return, scan the items to return, reshelve those items, go back through the aisles to put those items back. Now, if we did that in the wrong order, let's say we return the money before we scan the items, and then you find out that all the items weren't there and you returned more money than you should have. That's when you're messing up the transaction, you're messing up the batch. So that's the key part of transactions, forwards and backwards, and the order matters. So with that, you can create stored procedures. And this is like kind of the exact same as creating a function like in JavaScript or any other programming language, except it's for SQL. So stored procedures are queries that are stored in the database and can be run using its name. So just like you create a function and then you call on the function by writing out its name, you can do the same thing for a stored procedure. So how you would write that is create procedure, and then the name of your procedure and whatever input variables that you need, and then as begin and end. And anything between the real meat of the procedure is going to be between the keywords begin and end. And that's going to be a transaction, which is what we just talked about. And that is all I have for today. Are there any questions? All right, awesome. If you do have any questions, feel free to message me. Also, be sure to schedule your weekly code review with your mentor. I do appreciate you coming. Sorry for the mix-up, but I'm glad we were able to do it. All right, have a great day.